Hi students, in this video we are going to study about the experimental arrangement used to study photoelectric effect and what is the effect of intensity on the phenomena. Now this is the experimental setup used by scientists to study about photoelectric effect. The apparatus mainly consisted of an evacuated glass tube which consists of two electrodes which is the emitter, which is the emitter denoted by the letter C, made of photosensitive material, and second one is the collector E. Now this two electrode is connected to an external supply with the help of a commutator, and in the first case the collector was connected to positive side of the battery and the emitter to the negative side of the battery. This arrangement is what we call a potential divider arrangement, which is used to vary the external supply, which is used to vary the voltage supply. Like we vary that regulator of a fan, we use a potential divider to vary the potential. A microammeter was connected to the circuit to measure the amount of current produced, and a voltmeter was used to find out the external supply provided to the circuit. And there was a quartz window through which light of suitable frequency comes and hits the metal surface, and the energy from the light is absorbed by the electrons and they move forward. And since the collector is connected to the positive terminal, what happens? The electrons are getting accelerated towards the collector because of the positive field, and this movement of electron produces the current known by the name photocurrent. The scientists did various procedures, various ways to find out what is the effect of intensity, what is the effect of frequency, potential, external potential, etc. on the photoelectric current. Now first let us see what happens to photoelectric current when intensity of light changes. Now when I say intensity, it is actually intensity of light according to particle nature is number of photons passing through an area in unit time, or number of photons coming and hitting a unit area in unit time, and each photon can eject an electron, which means one photon can eject one electron from the metal surface provided the photon is having a definite amount of frequency known as threshold frequency. So as I told you, one photon can eject an electron. So when I am varying the intensity from 1 candela to 2 candela, 3 candela, etc., what happens? The intensity is varying, which means the number of photons coming and hitting the metal surface is increasing. And if those photons are having a definite amount of frequency, then depending upon the number of photons hitting the surface, that much number of electrons are produced, which will move towards the collector and produce the photocurrent. So effect of intensity on photoelectric effect. When the accelerating potential and frequency of the incident radiation is kept constant. Here one important point is the external supply is kept constant, the frequency of the incident photon is also kept constant. Only what is changing? The intensity, that is number of photons hitting per second on the surface is changing. It is found that photocurrent increases linearly with the intensity of incident radiation as shown below. Since photocurrent is directly proportional to number of photoelectrons emitted per second, it implies that number of photoelectrons emitted per second is proportional to the intensity of incident radiation. The number of photoelectrons emitted per second is proportional to what? Proportional to the intensity of incident radiation. So if we draw a graph for intensity of light versus photocurrent, we will get a straight line like this. So as the intensity of light is increasing, what happens? Photocurrent is also increasing. And in this experimental setup, what they kept constant? They kept the energy or the frequency of the incident photon constant, and also the accelerating or the external potential was also kept constant.